In this video, we're continuing section 5.4 on log properties, and we're going to do some more log property examples. Let's get some more practice with these. Okay, so I want to evaluate each expression. All right, so in part A, I have e to the ln of 32. So ln of 32 is the exponent. Okay, so one of the things I want to notice is, well, ln, that just means log base e. So I have e to the log base e of 32. So we've seen stuff like that before, like when I have a base and that whole thing is being raised to a log in the exponent, and the base and that log base are the same. Well, because they're inverse functions, they undo each other, and you're just left with the x. So that just equals x. Okay, so I'm going to highlight this. This is one of our log properties. We've also seen that if you do it the other way around, if you have the log on the outside and the exponential on the inside, again, the log and the exponential base, they kind of undo each other because they're inverses, and you'll just be left with that x. You'll just be left with that x, so that exponent in this case. Okay, so I'm going to highlight this one. So for our problem here in part A, it looks more like this. You got the exponential part first, and then you got the log and the exponent. And then the bases are the same because they're both e, right? ln is log base e. So they'll undo each other, and you'll just get the thing inside of the log, which is 32. All right, so that is our answer. Using this property, we get this. One quick step. All right, let's take a look at part B. So in B, it's kind of the other way around. I got a log on the outside, and then I got my exponential thing on the inside. Again, remember, ln means log base e. So the log and this exponential, they got the same base. So this time we would be using this log property, which says that, okay, that log and that exponential, they'll cancel, and you'll just be left with this exponent. And that exponent is 1,000. Ooh, let me write it. It is 1357. And there we got it. There we got it. Okay, we could have also done this by just converting it to exponential form. Like if I didn't know what this was, I could let it equal x. And if I converted it, well, the base of ln is e. So we'd be getting e to what power equals e to the 1357, right? Because it equals the thing that's inside. So then what's the exponent? Well, it's 1357. So I'd get the same thing. Okay, all right. So now let's take a look at two more examples, but let's up the difficulty a little bit. So I got this log expression. This is technically a log base 10 here. And then I got this exponential type thing. So I want to give you a chance to try these first. And the way I want to have you do it is try part C for 2 minutes and really time yourself. Just give yourself 2 minutes, probably just enough time to start the problem. And then at that 2-minute mark, move on to part D and try that one for 2 minutes. So give yourself 2 minutes for each. Again, you may not finish them, but that's okay. I want you to just be thinking about what are some of the key ideas? How might you begin these problems? Pause it in 4, 3, 2, 1. Pause it. Give yourself 2 minutes for each of these. All right, so hopefully you did that. Hopefully you paused it and tried these for a little bit. Okay, so for part C, I got log and it's log base 10 here, but the thing that's inside of it looks pretty complicated, and I don't really have a great way right now to multiply these. Because to be able to multiply these, I either need the bases to be the same, or I need the exponents to be the same to be able to use some exponent properties. So one thing I can do to make that happen is I can rewrite the 4. So I got 5 to the 6. And I can rewrite the 4 because 4 is 2 squared. So I got 2 squared, and that whole thing is being cubed. And then because I have a power to a power, I get to multiply the powers. So that'll give me log of 5 to the 6. And if I multiply the powers, that becomes 2 to the 6. Ooh, so I'm liking this. If I'm multiplying two terms and their exponents are the same, that becomes, I got log on the outside. I get to multiply the bases together. So it's 5 times 2. And that whole thing is being raised to the 6th power. So this gives me log of 10 to the 6th. Okay, so now I finally got it into a form I can evaluate. The base of this log is technically a 10. It's a 10. Oh, but that matches the base of this exponential. So they cancel each other, right? That's this log property. They should cancel each other, and I should just get that exponent, which is 6. Okay. And that's my answer. All right, let's take a look at D here. So D looks a bit more like this first property, where I got the exponential part first, and then I got the log in the exponent. Unfortunately, I can't just use it right away because this is a 4 and the base of the log is a 16, and those are not the same. So I need them to somehow become the same. Okay, so how can I do that? I'd really like the 4 to be like 16. So what I'm going to try to do is, can I rewrite the 4 as 16 to some power? Like 16 to what power will equal 4? Well, it's to the 1/2 power, right? Because a 1/2 power means I'm square rooting. Okay, so if I do that, this becomes 16 to the 1/2 power. That's the 4. And then that whole thing, the exponent is log base 16 of 5. Well, now what I have is a power to another power. So the powers get to multiply. So this gives me 16 to the 1/2 times log base 16 of 5. Can I cancel them now? Can I cancel the 16 and the 16 because they're the same? Well, unfortunately not, because there's a number in front of the log, right? In this log property, there's no number in front of the log. But we've seen an example before where we moved a number out of the way. So how can I move a number that's in front of a log out of the way? Well, it can come inside as the power. I could use my power rule. So this will be equal to 16 to the log base 16 of 5 to the 1/2 power. Now it's out of the way. Now the 16 and the log base 16 will cancel, and I'll just be left with a thing that's inside that log, which is 5 to the 1/2. Cool, and that's my answer. Or if I wanted to rewrite this, that's the same thing as square root of 5. I could also write it like that. All right, and there we go. One other way that I might have thought about approaching this is, well, could I have instead just change that 16 to something? Like to 4 to a power? So I got 4, and then the 16 I can write as 4 squared. And then I got 4 squared, and then I got a parentheses 5. There is a log rule for if I have an exponent here in the base. We just haven't talked about it. It's not a really common log rule, so I wouldn't expect you to know it. And we don't necessarily need it. Like, we could totally do the problem like this. But if you're curious, there is a log rule that I could use. So I'm going to call this method 2. And that log rule is, well, if you got a power here in the base, I can move it in front of the log, but when I do that, it'll become the denominator. So I'll get 4, and then instead of just getting 2 in front here, it becomes a 1 over 2. It gets reciprocaled, and then I'll get log base 4 of 5. So now, well, I can't cancel them yet because I got that 1/2 in front, so let's bring it up as the power. So I get 4 to the log base 4 of 5 to the 1/2, and from there, it's the same as before. So I'll put a dot, dot, dot. So in case you were curious, well, there is a way to do it by changing that 16, but it involves using a log rule that I haven't really talked about and I don't expect you to know. But if you did want to use it, this is how it works.